Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss how to insert a node in a sorted singly linked list in Java. So friends, let's suppose we are given as sorted singly linked list having 4 nodes, say 1, 8, 10 and 16. And suppose we want to add a node having data as 11 to it. Friends, here we want to insert this node such a way that the sorting order is maintained in the linked list. Therefore, in order to insert this new node into this sorted singly linked list, here is the algorithm for it. So currently you see the head points to first node having data as 1, then it goes to 8, 10, 16, and we want to insert the node having data as 11, and we want to insert in such a way that after insert the sorting order is maintained in the list. So let's see the working of this algorithm step by step. So in order to insert a new node in a sorted singly linked list, first we'll create a list node by name current, which will point to the head. So here if you see, the head points to the first node, therefore the current will also point to the first node. Then we'll create a temporary node which will point to null. So this while loop will execute till current is not equal to null and current data is less than new node's data. So we'll see this algorithm step by step, and after we complete this while loop you will come to know that why these conditions are needed. So here if you see, current should not be null, so current is pointing to first node and it is not null, and current data. So current data is 1 here and new node data is 11. So 1 is less than 11, therefore this while loop condition comes out to be true. So in first step what we'll do, we'll assign the value of current to temp. So current points to the first node, therefore when we assign the current's value to the temp, it becomes something like this. So now temp points to the first node, and then we'll traverse the current to its next node by assigning current dot next value to current. So current points to first node and next point to the second node, therefore we'll simply assign the current's next value to current. So it would be something like this. So now current points to the second node. Moving ahead, now again current is not equal to null and current data, which is 8, is also less than new node's data, which is 11. Therefore this while loop condition comes out to be true, and we'll assign current's value to the temp. So it would look something like this. And then we'll simply traverse current to its next position by assigning current dot next value to current. Moving ahead, so again current is not equal to null and current dot data, which is 10, is also less than new node's data, which is 11. Therefore this while loop condition comes out to be true, and we'll simply assign current's value to temp. So it would look something like this. And then we'll simply traverse current to its next position by assigning current dot next value to current. Moving ahead, so now current is not equal to null, and if you see current data, so current data is 16 and new node data is 11. Therefore current data is not less than new node's data, therefore this while loop condition comes out to be false and this while loop breaks. So if you see, we have traversed current to the node which is just greater than the value of new node, and we have also kept a temporary node which is just behind the current node. So the idea behind keeping this temporary node is once this while loop breaks out, then we need to insert new node just between 10 and 16 because 11 is the value between 10 and 16. So in order to put the node between 10 and 16, we need this temp node because this pointer will now be pointing to new node, and new node next, which is pointing currently to null, will point to current. So in order to insert this new node into sorted singly linked list, what we'll do first, we'll first make new node next point to current. So new node next currently points to null. So instead of pointing to null, now we want to insert it between 10 and 16. Therefore, this next should point to 16. And if you see, current points to 16. So we'll simply assign the value of current to new nodes next. So this is the step for it. So it would look something like this. So new node next points to 16, which is also referenced by current. Moving ahead. Now in order to insert the node between 10 and 16, temp next points to 16. Therefore we need to break this link and we need to assign this link to new node. So what we'll do, we'll assign new node's value to temp.next. So temp.next is currently pointing to current. We'll break this link and we'll assign it to new node. So it would look something like this. And finally, when we align this linked list, it will look something like this. So you see, we have inserted 11 just between 10 and 16. And also after insert, the linked list has maintained its sorted order. Therefore, we'll simply return the head. So friend, this was the demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorials, I have created a singly linked list class which has an instance variable of type list node, which is actually the head of our linked list. It also has a inner class by name list node, which helps us in storing the data in the linked list. So in order to know more about its working, please watch my previous tutorials. So in this tutorial, we will simply write a method which will insert a node in a sorted singly linked list. So I'll just create a method public and I will give a return type to it as list node. So let's say I give method name as insert in sorted list. This method will take an argument of integer by name value. So this value will be stored as a part of node into the sorted singly linked list. So first we'll create a list node for this value. So I'll give the name to it as new node. And then we'll give a condition as if head is null, then simply return this new node. Moving ahead, we'll create a list node current, which we saw in slide, and we'll assign a value head to it. Then we'll create a list node by name temp. We'll assign null to it. So first we'll create a while loop. So in this while loop, we'll provide a condition as current not equal to null and current dot data is less than new node dot data. So we'll iterate till current is not null and current data is less than new node's data. So in while loop, first step would be we'll assign the value of current to temp and we'll simply traverse current to its next value. So basically these are the two statements which we'll be providing into the while loop, and after while loop gets executed, we know that that current now points to a node which is just greater than the new node's data, and temp points to the node which is just lesser than the new node's data. Therefore, first step would be to new node next will assign the value of current, and then to temp next will assign the value of new node, and finally we'll just return head. So friend, this is the method by which we can insert a node into sorted singly linked list. So here if you see in the main method, currently there are 4 nodes by data is 1, 8, 10, 16. So they are the same what we saw in the slide. So if I print this singly linked list, you can see it print as 1, 8, 10, 16 and null. So therefore currently this is in sorted order, and let's suppose I call the method insert in sorted list and give the value as 11. So friends, once this method is executed, it will insert 11 into sorted singly linked list. So I will just print it again, and if I run the program, so currently it was a sorted linked list, and after insertion of 11 the sorting order is still maintained. So this is the algorithm by which we can insert a node into sorted singly linked list. So friends, I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.